Unit 9, Lesson 2, we're going to learn two new definitions and then continue to use sine, cosine, and tangent to help us answer some word problems. The two definitions you need are angles of elevation and angles of depression. So the first one, an angle of elevation, is an angle that is created when you draw a horizontal line and the line looking up towards a specific object. So if you look here, that's exactly what I have drawn. So imagine you're standing right here at this point and you draw a horizontal line straight ahead, like you're just looking straight at the wall. Then if you look up at an object, say an airplane or a bird in the sky or something, the angle that's created between those two lines is what we call the angle of elevation. That's it. The definition of angle of depression is when you, the observer, are looking down at something. So now you're standing, say, up high on a point or somewhere like that. And then, again, you have to look straight out and create a horizontal, and then look down at whatever object you're looking at. And then the angle that you're creating there is what we call the angle of depression. So the key to both of these definitions is it's an angle created between a horizontal line and then looking up or looking down. If you're looking up, it's elevation. If you're looking down, it's an angle of depression. So what is going to be very helpful to you is drawing some pictures of the situation you're looking at. But you have to understand, both angles of elevation and depression are going to be in your diagrams. You got to make sure you get the right one. For example, in this first picture, if I was the airplane looking down at the tree, the airplane looking straight ahead, and then looking down at the tree, since it's looking down, that's creating an angle of depression. Versus if I was, say, a squirrel on the ground at the tree, I could look straight ahead and then look up at the airplane, and that is an angle of elevation. And it's very easy to mix the two up, so make sure you draw your pictures accurately. Here's another diagram where, say, someone's standing up on a platform or on the top of a building looking down at someone else. You need to understand that the line that they're looking at would be straight from their eyes. So they may be up 5 feet because that's how tall they are, but that straight line looking ahead and then looking up, that's the angle of elevation for that person. Whereas the person who's up at the top looking straight ahead and looking down, that's the angle of depression. So you'll notice that they both use the same line. Looking at the object never changes, but looking straight ahead and down or straight ahead and up is where it changes. And the next picture is my favorite one that I need you to be aware of. Sometimes one person or an observer could be looking at two objects at the same time and then asking questions about, well, how far away am I, or things like that. So that person looking straight ahead creates the horizontal line, but then as they look up towards the airplane in this picture, that would be an angle of elevation. But as they look down at the boat, that would be an angle of depression. So understand that an angle of elevation and depression is going to be present in every picture you draw, and then you need to use that to help you figure out some information. So let's look at a couple examples of that. In this first example, it says the angle of elevation from a sailboat to the top of a 121-foot lighthouse on the shore is 16 degrees. How far is the sailboat from the shore? Well, first I'm going to underline that word angle of elevation. That means I'm looking up at something. So what I like to do is draw this picture. Don't make fun of my art skills. There's my sailboat, and I'm looking up to the top of a 121-foot lighthouse. So there's a lighthouse over here. I got a roof on it. There we go. So this is 121 feet tall, and we want to know how far is this sailboat from the foot of that lighthouse. That's what I don't know. Well, if you look at this, what I've created is a right triangle with the height being 121, a distance I don't know, but it said the angle of elevation was 16 degrees. So when that sailboat looked forward and looked up at the top of the lighthouse, then that angle of elevation was 16 degrees. And now I have enough information to solve this problem. I'm going to redraw this picture over here just as the triangle now that I've created, because that helps me see it better. So on this triangle, I'm trying to find this bottom length. I know that this height is 121 and that this angle over here was 16 degrees. So now I go back to my first lesson. I think, okay, 121 would be the opposite side of that 16 degrees, and x would be the adjacent side. Well, the trig ratio that uses opposite and adjacent would be tangent. So the tangent of that 16-degree angle is supposed to equal the opposite side 121 over the adjacent side of x. So now I have my equation set up from the trig ratio. I'm going to go to my calculator and say, what is the tangent of 16? The tangent of 16, it tells me, is 0.287. And I double check to make sure that I am on degree mode, and I am, so that's correct. And that's going to equal my 121 over x. So now it's just a solving. I multiply both sides by x, so I get 0.287x equals 12, which means I need to divide by the 0.287 to get x completely by itself. So I'm getting 12 divided by that 0.287 is 41.81. So I am 41.81 feet away from that lighthouse. So this is 41.81. And that's how we use angles of elevation to help us find distances from certain objects. So let's look at an example of angle of depression. In example 2, it says a sonar operator on a cruiser detects a submarine at a distance of 500 meters and an angle of depression of 37 degrees. How deep is the sub? Well, a cruiser is going to be a boat that's sitting up here on the water. So here's my water. And it's trying to detect a submarine that is down here somewhere, maybe with its telescope looking around. So there's my submarine. It says the cruiser detects the submarine at a distance of 500 meters. Now this leaves a little bit open to interpretation. I interpret that since the cruiser can only detect how far it's going to travel on the water, from the cruiser to the submarine along that water is 500 meters. And it says the angle of depression is 37 degrees. So if that cruiser were to look directly at the submarine, then the angle of depression is 37 degrees. And again, remember, I looked out and then I looked down at an object. That's what we're calling angle of depression. So that's where my 37 degrees go. And it's asking me how deep from the top of the water down to the sub is that submarine. So if you draw this picture, hopefully it creates for you some sort of right triangle, because we drew a horizontal and a vertical, how far and how deep. So I'm going to redraw that triangle. You don't have to, but I want you to be able to see it just as a triangle. So over, down, and up. And that was a right triangle. So on my triangle, I had sides of 500. I wanted to know x, and I had an angle of depression of 37 degrees. So looking at that triangle, the opposite side of that 37 degrees would be x. The adjacent side would be 500. So I'm looking at another tangent relationship, because when you compare opposite and adjacent, that's always going to be a tangent. So the tangent of that 37 degree angle should equal the opposite side x over the adjacent side 500. Now this is a slightly different setup for the equation. Again, I'm going to go and ask my calculator, what is the tangent of 37? What's that ratio? And it's telling me that it is 0.754 equal to that x over 500. In this example, I don't need to do any dividing by variables. To solve this equation, all I really need to do is multiply both sides by 500. And that's going to give me x completely by itself on the right side. So I just need to take 0.754 times 500, which is 377. So this depth of my submarine must have been 377 feet. In our third example, this is just a review of what grade of a road means. Grade of a road is always a percent, and percent means per 100. That's what it means. So when you draw this, imagine you have a road that is a hill. So you're driving up this hill. 5% grade means that for every 100 feet across, you're only going up 5. Essentially a slope. 5 over 100 would be your slope. But you are putting it in terms of percent, so 5%. So what angle does the road make with the horizontal? Well, that would be this. The reason I put this in this chapter is because technically, grade, you have something looking straight ahead, and you have something looking up to a point higher. X in this case is an angle of elevation, so it applies all the same things we've been doing. So to solve this, I have to set up an equation, and I see that 5 would be the opposite side, 100 would be the adjacent side. That's another tangent. So the tangent of that angle x is going to equal 5 over 100. Here again is a different setup. I'm going to solve this different. If I'm looking for the angle, I have to go to my calculator and say, what is the angle that has a ratio of 5 over 100 for tangent? And to ask the calculator, that's what we call the tangent inverse. So when I type in the tangent inverse of 5 over 100, I'm getting that that is a 2.86 degree angle. So when the grade of the road is 5%, you're going up at roughly a 3-degree angle. And for degrees, I'm totally okay if we just round that to the nearest degree. So that's about a 3-degree angle. So here are 3 basic examples of angle of elevation and angle of depression and how each one of them is solved differently. You may start to notice some patterns. For example, you notice that tangent was used in every single one of these problems. That's very common, but not necessarily always true, so be careful. Also, you cannot come up with and say, oh, I always have to multiply by this number. I always have to divide by this number. Use the trig ratios to create yourself an equation and then solve the equation just like you would any normal Algebra 1 equation. That's the end of this video. If you want to watch more examples of this, watch the second video, which will take you through the rest of the examples in your notes for this section. Good luck.